what we had pending from the presentation before was to test some of the tools that I described, okay? Let's go with each of them like in time. So first one that I mentioned was, for example, was the address6 tool, and it was about printing addresses in different formats. And maybe when I was describing this without, showing you, an example, it wasn't that easy to see. So let's say, for example, that I have an address such as this one. So if I print the address in this way, this is supposed to be, or I can write it this way so that it's more clear. So this would be the canonic form of the address, okay? Which usually, if you are logging or if you are configuring, system or something, that obviously the way in which you write down the address. But normally, if you want to process an address with a script, like a regular expression or something, these addresses in that format, they are not that helpful. So usually you want something like this. And if you have done some scripting, you could probably tell why it's easier, right? It has like, for example, if you try to come up with a regular expression to be able to pick every possible IPv6 address, that's a pain. That's a pain. I have something, let's say called, it's not easy to see there. Let's see. This is really like the regular expression, and actually still has like a small problem that I need to fix, okay? Obviously, I was proud of myself when I came up with this. Now I would be proud of myself for understanding it. But because of the, all the possible ways in which you can write the, the addresses, like compressed forms with more zeros, with less zeros, and so on, it's actually a pain if you want to do a script. So the idea is that you want to move away from this. So if you print the addresses in this way, obviously it's much, much, much easier if you want to analyze the addresses such as a text string. Another thing that I mentioned was that the tool could actually produce like a set of prefixes as a result from some addresses. So let's go here. So I have a text file. Obviously it means nothing. It's just like a bunch of addresses, which I could have got these addresses, for example, by mapping some domain name to the query record. It's quite simple. Now let's assume, for example, that I wanted to do DNS reverse enumeration for these prefixes. Well, obviously I have to come up with a prefix for each of these, okay? So what you can do is, for example, if you pipe whoops. Print unique prefix. I think it was this one. There you go. So these were the addresses. Now what we got here is we have /48 prefixes that we got from the original addresses. I mean, obviously that's trivial. You just need to set to 0 all the low order bits and just add the /something to make them a prefix. Now, with these prefixes, you can, produce DNS reverse enumeration, for the corresponding prefixes. So the idea of these small tools or these small features is that eventually you can, build a tool where you can automate everything. So you get addresses, automatically you produce prefixes, and out of these prefixes you do DNS reverse enumeration, and so on and so on and so on. Like the tool that I was describing before that puts everything together needs this kind of stuff so that when you get addresses, you come up with the prefixes so that you can do DNS reverse enumeration. Okay? What else did we talk about? We talked about search engines. So, for example, you can, one of the search engines that I described was Bing. And if I run something like this is for the top level domain military, okay? The tool, obviously, as I was describing before, eliminates duplicate results. And also, once it, spends some time finding domain names, for example, it finds this one, then it tries to go deeper into the hierarchy, okay? To try to find as many as possible. Okay. This is the same thing, or should be the same thing if you run with this other search engine, Teoma. I mean, the order and the results might be different, but the idea is exactly the same.
So it's running until you're aborting it?
No, actually, I stopped it myself, but it has like a kind of like limit. For example, the tool internally says, okay, if I visit so many pages without actually getting any new results at all, eventually I will give up. Now, obviously, there's a trade-off between, trying to get all the results and for how long you need to wait. Because what you are doing with a search engine is, for example, specifying this. Now, you might get like multiple pages, pages of, search results, in which, yeah, the pages are different, but all correspond to the same domain name. So the tool has to play some tricks inside to actually, try to get to different domain names. And eventually, if it tries and gets nothing, eventually it stops. So, for example, when I was running the tool to actually try to build like a zone data, I was leaving the tool running for maybe like a day. And obviously, once it has already run for like, let's say 4 or 5 hours, maybe it gets like a new domain name, like every 5 minutes. So there's a trade-off there. For me, much of for me the main usage that I was given to this tool was to come up with zone files that I didn't have. And the other tool that I mentioned. Was a tool that puts everything together. So what you do is, I mean, this is very, very preliminary version of the tool. You start, for example, the H option gives like hints to the tool, okay? So you are telling the tool, okay, I know this information about this site. Like you might know some domain name, you might know some prefix or something. It's information that you give to the tool. So I could start, for example, just with the name of, with some domain name, okay? So this is, the H is for hints. And then you can also set the F. F is for filter. So that means if I set the F to the domain name, that means that I'm going to require the results to belong to the domain name lagnic.net. Okay? If I just do this, this is just a hint. I'm telling the tool, try learning domain names and IP addresses and IPv6 addresses and everything starting from here, but I don't care where you get the result from. So it could be from a completely different domain name zone. And in practice, unless you are trying to map the whole internet, well, that's not of much use. If you are trying to do a pen test of a site, obviously you want to reduce the, the DNS zone or the prefixes or whatever that is. It can take some time, but I was running the tool already. So this is the results that I was getting with the tool as I was running it before. Essentially, the tool gives you two different kinds of output. One is domain names, the other one is IPv6 addresses. Okay? The tool eliminates duplicates. So if there were any duplicates, in the DNS reverse enumeration or anything, you're going to get only one copy. And as I said before, since I'm using filters, you can see that, for example, all the domain names belong to lagnic.net, which is what I was specifying in the tool. If I were to run, for example, the tool like this, without the filter. Okay, here I run it without the filter. So you see that, for example, you have like rin.net, which has nothing to do with the zone that I was targeting. Okay? So you can tell the tool, start finding names and IPv6 addresses from here, but I don't care where you get the results. So you get stuff like this, which in most cases is not going to be useful for you. And if you don't want that, besides specifying a hint, you also specify like a filter. And this means start from here, but I also require you that the results that you show me belong only to this DNS zone. And you can also specify prefixes. So you can say, okay, I know that my target network is that specific one, so I only want results belonging to this domain name and some specific prefix. The tool, essentially runs in a loop. It gets domain names, starts with getting domain names from a search engine. Then from those domain names, it obtains different kinds of DNS records, NS, MX, and so on. It obtains IPv6 addresses, and then it performs DNS reverse enumeration. And it goes in a loop until you get to a point in which you don't get any more results. That's where the tool stops, okay? Yeah. Okie dokie. ¿Cuál era este? So I'm going to continue with the next part of the talk. Essentially, much of what you have seen in the, what I presented in the previous talk was motivated by this other work, okay? So again, I was trying to build like a database full of IPv6 information, like domain names, IPv6 addresses, and so on. And then, I had to figure out how to get that information. One thing that is important is that, for the project that I was working on, I didn't just need like IP addresses, but I wanted, for example, I needed to also learn what were the corresponding domain names for them, okay? just having random addresses can be useful for some things, like for an attacker that, just wants to, find some vulnerable device. But for many other things, what you want is, to learn information about, systems that are important for you. So this is this is where I started from. Like, say, okay, let's try to build like a database with all this information. And then the question was like, well, how do I know, for example, that in my database I have like information about systems that are supposed to be important, not about just some random system out there that nobody cares about. Like, for example, you want to learn information about the websites of government institutions, security sites, and all of that. Obviously, ideally speaking, you might be able to get the DNS zone file, okay? I had never actually bothered that much about that, so when I got into this, I started researching a little bit, and it was kind of surprising to me that the information that I found available, which I will discuss later. Even there are like more basic questions. Let's say that this is not just something for pen testing. For example, one of the things that I wanted to do was, for example, measuring IPv6 deployment. For example, let's say that you wanted to say, I want to measure in Germany the extent to which IPv6 is deployed in, let's say, education sites, government sites, private sites, and so on. You have to find a way, for example, how to map all those sites. And if you want to do that at a larger scale, well, you even need basic information like what are the suffixes that different top-level domains employ. Simple example, like in many countries, a commercial site uses com dot the top-level domain. But for example, in the UK, they don't. They use co, not com. Obviously, the one in the UK is an easy one, but if you want to do that at mass scale, it's not that simple because you have to, wonder about, every single possible TLD. So these were all questions that, I had never wondered, but now I needed some answers. The other thing was to try to figure out, to what extent some of the techniques that we had been employing for, targeting specific sites could be used like more at the larger scale, okay? Usually if you are targeting like a single site or a single company, the scale of the problem is more reduced. Usually more, you might know, for example, some patterns that the addresses might have and so on. But if you want to do that if you want to do the same thing but mass scale, it's not that simple. First one, some files, okay? I had never bothered much about this, and I have a friend in a regional registry in Chile. So for people that work in NICs, this is stuff that they are more aware about that. And the question was essentially, well, I'm interested in as many domain names as possible. Where can I get them from? So the piece of information that I already had was, these 3 different lists of important or popular domain names. I have put them available on GitHub. Actually, I put it there for myself. Usually, I need to look at those files and I never know where to find them. So if you synchronize that Git repo, you get the 3 lists. One is Alexa's top 1 million site. I think that they don't. I think that they don't put that list available anymore, as far as I remember. They do?
No.
Okay. I think that at some point they stopped publishing that list. So, I mean, you don't know if the list that we have right now is really the top 1 million more important sites, but you don't care. Then there is that. I think it's a company, Majestic. I don't even know what they do. I think it's like SEO or something like that. But they had something similar to Alexa. I don't remember if it was 1 million sites, but again, lots of domain names. That's good. And the umbrella list, I think, is published by Cisco. I don't know what for, but when I was searching for that, I found that. So that gives you like 3 different sets of domain names that are popular. Still, that doesn't give you much about less popular sites that you might be interested in, like military sites. You're not going to get anything there. So let's see. So originally I said, okay, if we were able to get the DNS zone files, will be great. I mean, is that information available? So I was talking with this friend of mine. I wasn't even aware about this, and apparently ICANN, which makes a lot of money, in the business of DNS, among other things, they set up that website, and the idea, kind of, the way I understood about that, is that if you are the administrator of some top-level domain, you can voluntarily join and share the the zone data for the zone you administer. Okay. It had been a long time since I had looked at top-level domains in detail. I was surprised with the amount of crap that you find on the TLD. It's like anything, anything. So there was a time in which it was .com, .edu, .org, and the top-level domains. Now it's .anything, essentially. It's like hundreds of top-level domains. What are the interesting ones that you can find over there? For example, .org is available, and for free, and you get the official zone data. So you can get all of the .org sites. Another site that I found quite interesting, and that's actually an interesting point of view, there's the people from Sweden, in which they actually publish the whole zone data on their website. And what they say is like, well, one way or another, if people really want to use this information for attacks, they're going to get it anyway. So what we assume is that if we publish this information, we will allow people to do research, for example, to measure things on the DNS zone for Sweden. So if you go to that site, you can essentially download everything for .se and .nu, which I don't know what NU is for, but it's something related to Sweden. There are other interesting ones, like this one, which somehow the zone data for Russia was leaked out. So you can also, get that one. And I don't remember where, but I did find some copy of the .com zone, which is probably among the most interesting ones. So this means that besides the list that we had in the Alexa Top 1 Million, Majestic, and Umbrella, there's actually a bunch of stuff that you can actually get if you research a little bit. As a kind of advice, because I see, yeah.
One question: have you looked at the certificate transparency log?
What do you mean?
The certificate transparency, that's the Google thing where all certificates must be listed that are newly generated, for example, from Let's Encrypt and so on.
No, I haven't, but that's interesting too. Yeah. So far, these are the ones that I looked at. And I was going to mention that for the first one, essentially, well, you have to create an account on the website, but obviously that's all free. Now, the funny thing is that nowadays, since it's a business, it's an industry. So, there's a company, let's say Amazon, they go and they want .amazon, so they go and pay $1,000 to get that, and essentially every big company does the same thing. So now you have at the top level domain, thousands of domain names. When you get to that side, the easiest thing that you can do is just apply for all, because you have to tell them which zone files you want. Obviously, if it's free, I want all. That's the mentality, right? And I did apply for all. Now, the funny thing is that somehow, I don't know how it works, but you get a notification when your access request is approved, and then they end up mail bombing you with thousands of emails in a second, which ended up causing trouble in my mail server. Because of these guys were bombing emails, approving, and for some reason, For each zone that you get approval, I was getting like 2 or 3 different emails. So it was like 3,000 TLDs multiplied by 3, so it was 9,000 emails in a couple of seconds. Let's say from a programming point of view, I would have aggregated the notifications into a single email, but the guy at ICANN thought otherwise. Okay, so there's a lot that you can get there. Still, we are not getting much about, other, let's say, less popular zones, like military sites at one place or another, universities, and so on. And obviously, those are interesting. I was measuring just a little bit, but in places, and that's, traditionally it works that way. Like, in educational sites, you get interesting stuff. Usually, I don't know if that's everywhere, but they don't care that much about, how everything is set up. So you get some interesting and very open setups, so to speak. So what can you do about them? Well, what I did is use the tools that I was describing before, like, for example, get Bing, to actually try to get as many domain names for each of those zones, okay? Obviously, you are going to be like very, very far away from the actual zone for different reasons. One is that in some cases, there could be systems that have nothing to do with the web or FTP or those kinds of services, so they might not be indexed into Google at all. But at the end of the day, it's something. Just to give you some idea, I think I had left like this tool, Get Bing, running for about a day, and I got about 65K different domain names, for example, for the UK. Okay, so you can get like a fair share of domain names. Obviously, after that, you can elaborate a little bit more. Let's say you could start from the domain names that you have. You could, let's say, get the homepage for that domain name and just scrap the HTML, because there might be links to other places or domains that you might not have yet. So let's see. I wanted to show you how you can do this sort of thing in a very automatic way. I wrote it down here so that I don't forget. So in the same script 6 tool, you have a bunch of tools. They don't do much interesting things, but they are useful. Like, for example, let's say that you want to know all the top-level domains for a continent. Like, I want to do measurements in Europe, okay? So I need to know what are the different top-level domains. So just run the tool like this. Now, obviously some you can recognize. There's Belgium and so on, right? You could already start using the Get Bing tool with this output. You can do something like this. When you run it with the batch, rather than taking the domain name from the command line, it reads domain names from standard input. So what's going to happen here, you get the first command that outputs the top-level domains, and the second, which takes each of those top-level domains and uses Bing to actually find domain names. So you start getting something like this. That was the first one that was in the list, okay? .al, I think it's Albania or something like that, okay? Now the tool will run and run and run and run and run. Eventually, when it doesn't find any more domain names for Albania, or if this is Albania, it will switch to the next one, okay? Obviously, this is a trivial way. I mean, the idea of these tools was to be able to automate the thing of, for example, discovering different zones. There's another thing that you can do. Let's say, for example, that you want to target some specific country, okay? We were talking before about the UK, and we were saying that in the UK, if you have a commercial enterprise, it's not .com, it's .co, okay? There's this tool which gets you the suffixes for some specific top-level domain. So I run it with UK, and what you get is ac.uk, etc., etc., etc. So in a similar way, instead of showing it on the screen, I can pipe it and now the tool again will start building like the data for each of the suffixes. Usually the more specific you are about the domain you specify, the more results that you get. So that's why it's usually a good idea if you want to target like a specific country, rather than just giving the tool like the top level domain like UK, you use the other tool to produce the suffixes too. So I could run the tool like this. I could just specify UK. Oops.
How is your tool working? Is it a predefined list or?
I think that for this one, as far as I remember, I found on the web some file which was kind of like a text file, so I figured out the instruction how to parse the file. And as far as I remember, the toolkit now contains a local copy. So essentially what it contains is like, the top level domain, and below that it contains like the different suffixes. And for some places it's quite interesting. This one I remember because, in order to parse the file, I had to go through it because it didn't have like a very, very specific format. For example, for Brazil, look at all the ones that you have. Because, for example, they have like, for the second level, they have like different names for the cities and so on. So for many countries it's quite interesting. I mean, you might assume, okay, well, every country has .org, the name of the country, but for example, in this case, if you were just focusing on those, you'd be missing a lot, okay? This is just one example that I remember, that a country that has, the second level of domains with so many. I think that in Germany, you don't have like a second, it's like kind of like flat, right? Uh-huh.
So let's ask your tool.
Yeah, well, yeah, let's see. Yeah, nothing. Okay. Then you also have things like, for example, this is if I remember correctly. So in this case, you get top-level domains for different regional registries. Okay? For example, this is something that I needed to some extent because I was doing measurements for the area of LACNIC. So I didn't just need the continent, because for political reasons, I guess, there are parts of Latin America that belong to ARIN and not to LACNIC. So, for example, for measurement purposes, you can do something like this, right? The same thing for, Afrinic, and so on. So different ways to, query a database so that you get the top-level domains that you might be interested in. Well, for continent, I said all that. Okay. Again, with this one, with Bing, you can let the tool run for a long time and build your own database. With Tioma, you're going to get banned. So, using Tioma is just for targeting a specific site, because after that, you are going to be blocked. Other stuff. This part of the presentation, or this second presentation, again, was about building a database with IPv6 related information. So, previous slides was a discussion about stuff related to domain names. Now the question was, what about addresses? Years ago, like maybe 5 years ago or something, I had done measurements analyzing the addresses that were employed by popular web servers, mail servers, and name servers. Okay? What I did at the time, that was published in RFC 7707, is essentially start from the Alexa top 1 million domains, obtain all the query records, and analyze the addresses to see what are the patterns that the addresses follow. At the time, we are talking maybe 5 years ago, most of the servers had very predictable addresses, okay? Like low byte addresses where the interface ID is virtually all zeros except for the last byte. So when I was looking into this, I said, okay, let's measure that again to see if that situation changed. Now you might wonder why could it have changed? Well, in the recent years, there were 2 RFCs on the topic that were published essentially to replace the traditional scheme for Slack. So with Slack, usually you used to put the MAC address in the interface ID, and what these 2 RFCs says is that instead of putting the MAC address, you should put a random number there. So the question was essentially, well, has the publication of this document resulted in any changes in what we see on the internet? So I did the measurements again, and to some extent, I was surprised about the results because I don't follow, I don't really understand the results. So these are measurements, or this is an analysis of the IPv6 addresses corresponding to web servers. So I got the Alexa top 1 million domains, and for each of those domains, I obtained the query records. And for each query record, I analyzed the address to see what was the pattern that the address was following. So you have, the references here. What's interesting is that this bit over here, which I think is something like, I don't know for this one, no, for Alexa, maybe it was something like 15% or something like that. This one, the larger part, is addresses that embed an IPv4 address in the interface ID. So that's a very common way in which people configure their servers. Like if you know, for example, that your server has the address, say, 10.10.10.10 in IPv4, in the IPv6 world, you have the IPv6 prefix, and you put your IPv4 address as the interface ID. Why? Because, well, if you remember the IPv4 address, then it's easy to come up with the IPv6 address, because it's just the v6 prefix and the IPv4 address. These are the same measurements, but using the list of domain names that is available from Umbrella. Okay? Umbrella was the list that I was telling you that is distributed by Cisco. I don't know what for or why. Now, what's interesting here, look at the number of random addresses. It's actually quite large. When I did the same measurement about 5 years ago, usually you'd find like only 5% of addresses that were random. All of the other addresses were predictable one way or another. They were like low byte addresses with the interface ID set to all zeros. They were addresses that were embedding an IPv4 address or something like that, but certainly not that many addresses. So certainly not as many as these ones. Now the part that I'm curious about, because you could say, okay, well, the reason for this is because we published those 2 RFCs, so now people replace whatever they were doing with the new scheme, okay? Now, the part that I'm curious about is that you still have the same number of addresses these ones, the ones that embed the MAC address. In the measurements that we did, like 5 years ago, we measure the same number of IPv6 addresses with MAC addresses. So I'm really wondering why this is the case, why we have so many randomized addresses. Because it's not that we had like lots of addresses with MAC addresses and that they were replaced with the new scheme. That's not the situation there. So I don't know why. I mean, this could be an indication that people used to do manual configuration and now they rely on the Slack addresses. I have no idea. But this was kind of like a surprise. When I was measuring this, I was expecting to get like roughly the same results that I got like 5 years ago. And these are same measurements, but again for a different data set. You can see that the results change quite a little bit. But in all cases, like this is addresses that embed IPv4, the majority, and in the previous ones, it's kind of like the same. These are, you see, the ones that are more popular, so to speak. Now, what you can essentially conclude from these measurements is that when it comes to target like public servers, like public web servers, mail servers, name servers, and so on, you can still rely on the patterns of addresses for the most part, because all of these here, and actually these ones too, are predictable. So it's only these addresses that are random and that you cannot really target like with the usual ping sweep. Still, all of these addresses are predictable. So while obviously things like doing DNS reverse enumeration is very, very useful, still people are using predictable addresses, and that makes life easier for the guy doing the pen test or the attack or whatever that is. Well, this is something that I was mentioning too. Again, according to the measurements that I did, that I was presenting in the previous slides, there is even in the worst case scenario, you have at least like 15% of random addresses. That's still not good. You might want to have much more of random addresses, but it's a big change, if you want, from the measurements that I did 5 years ago, where the amount of random addresses were about like 3% or 5%. The only thing is that I cannot really explain the results, because it's not that we replace the MAC addresses with these random numbers. So we still have the same amount of addresses with that use MAC addresses, but for some reason there are some addresses that converted to using random interface identifiers. So I don't have an explanation for that. PPP. So far most of what we did here was to cover finding servers, if you want, whatever kind of end system that is. There is also the thing that if you are building a database, you might want to find routers. Obviously, that's straightforward. You use traceroute, and the only thing that this tool does is essentially run traceroute, but eliminate the last address, because the last address doesn't correspond to an actual router, but to the server that you are targeting. Okay? So for the purpose of mapping the IPv6 internet, what I did was, once I got so many addresses of servers of different kinds, then I did traceroute to each of them so that I would find the routers in all of the directions. Okay? Actually, what I did, I have virtual machines in different places, like different countries, because, for example, if I do the traceroute from, let's say, Argentina, you go through some route. Okay? But for example, your packets are likely not going through, let's say, Asia, usually, okay? So what I did was two things. First thing was using virtual machines that I have in different places. That's one thing. The other thing, you probably use it, Hurricane Electric. they give you like free IPv6 tunnels, which for production maybe is not that great if you want. But one thing that is interesting is that they have POPs in lots of different places. So you can get like a tunnel with an endpoint in Japan, you can get a tunnel with an endpoint in different places. So I was doing I got like different tunnels, not because I was interested in the tunnel itself, but actually so that I had a point of presence in places that I otherwise wouldn't be able to measure. So I ran the same trace route using a tunnel in Japan, I ran the same trace route using some tunnel in the US, the same tunnel in Europe. So now if you do the math, let's say the world is America something here, there's Europe here, and there's Africa here, and Oceania here. And you start with the servers, and then you have the POPs that Hurricane Electric gives you, for example. So you do this from here, from all over the place. So obviously you cover a much interesting region in that respect. You probably didn't get all of the routers, but you do get a large number of them. What else? Okay. Some notes on DNS reverse mappings. Of course, I was using all of the techniques that we know so far, essentially using them and trying to use the information that I already got as input for doing something else. And, you know, among the things that I did was use DNS reverse mappings. Now, let's see some of the things that I found. One day I left a script somewhere running a DNS reverse enumeration for some prefix, right? Some weeks later, I go back to the server and I get like something like 2 gigabyte file of the result. So I say, well, that's great. I learned a lot. Now, not so great, because these people, this guy was, this particular example was Yahoo. They have all these, I think they are like dynamically generated, you know, DNS records. So for an address space that they have, but they don't really use, so my 2 or 3 gigabyte file was essentially all of this for all of their addresses, okay?
It's the same for Deutsche Telekom with the dynamic prefix.
Uh-huh.
And you're doing this, so you get for every single IPv6 address, you get a name, and the name just has the IPv6 address encoded.
So it's not just a wildcard, so it's a different name for each address.
So every single IPv6 address out of the dynamic prefixes range.
So that makes the thing interesting, because, I mean, I haven't done it yet, but one would have to start to think about doing some sort of filtering on this, because obviously having 3 gigabytes of this stuff, it's not worth it. And I did try many of these addresses because, I mean, there are some funny names. Some of them, they said irony of I don't know what. I mean, even here, you see it's migration, blah, blah, blah. So I did try the addresses to see if, you know, some of them were usable, if they were reachable. No, the whole address space is empty, essentially. So they have reverse mappings, but the addresses are not useful for anything. So for the purpose of, you know, my project, this was a waste of time and a waste of resources, because obviously I had then to enter all of this. So what I'm doing in my project is entering all of this information in a database, and for each of these, you know, each domain name, each IP address and so on, I run like a lot of tools, like a lot of different tests, like for example, a port scan, just to give you an idea. Now, if you got like, you know, 10 million entries of these ones, then you're wasting your resources for 10 million addresses where you're not going to find anything. So my, you know, without knowing in Deutsche Telekom, you said that it was the case? Well, I didn't know about that one, but I did find, just by simple inspection of the files, because, you know, when I got so many results, I say, well, what's going on there? There's noise too in the, you know, DNS reverse enumeration. So in my to-do list, I have to figure out how to enforce some sort of filter. I think that in the DNS reverse enumeration that Mark Oyst implemented, he tried to do something like do a DNS reverse mapping of, let's say, 5 or 6 different addresses, random addresses, and if all of them map to something, then you assume that there is some kind of like Wilcar going on. Still, this is stuff that I would have wanted to eliminate. Another thing that I got from, as conclusion from some of the tests that I did without actually inspecting so much about the reason for the reason for which the things were happening. In my experience, when you are mapping, when you are trying to map a network with DNS reverse mappings, if you do the reverse mapping with a /32, in many cases it fails. I guess that when you go more up in the in the DNS tree, for some reason, I don't know if some packets are filtered or what, but I wasn't getting much information that way. So as a result of that, what I decided was, rather than try to do DNS reverse enumeration with /32s, do it with /48s. And you might say, well, what if I have a /32? Well, you can use a script and produce, for example, 65K /48s. Okay? So you are covering the same information, but rather than starting more up in the tree, you want to do it like with with longer prefixes, because otherwise it doesn't work. What else? Other stuff. This is, I'm mentioning these things in these slides because for quite a few of these things are things that I had never paid attention anymore, and when I found them, I said, well, how come that I had never looked at this? So I don't know if you have ever checked this site. It's awesome. PeeringDB, essentially, I'm kind of like surprised that it actually works. So it's essentially a project that is not for profit, okay? And what you find there is information about, I don't know if all, but about a lot of IXPs. Internet exchange points, okay? Internet exchange points like everywhere. What kind of information can you find over there? Like anything, like the postal address of where the place is, email address, telephone addresses, and so on. But for the purpose of this project, what was quite interesting is that for each IXP, which you can actually list them, like you go through the site and you say, okay, I want to produce a list of all the IXPs that there are on the planet. You can obtain the subnet that is employed for the peering. Like, let's say in this IXP they are using blah 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 /64. And you can also learn the IPv6 addresses that these routers are using for peering over there. So what I'm saying is, with in the previous slides, I was learning IPv6 addresses of just random routers, which is okay. But the interesting thing here is that from an importance point of view, these routers are actually much more interesting. Let's say a bad guy that had an exploit for a router would probably be much more interested in attacking some of these systems than in actually attacking some random router out there. On this website, other than the like a web page where you can actually do your queries and without much work, they also have like a RESTful interface for doing the queries. So you can codify your query in JSON and you get the results in JSON. So it's quite easy to produce a script to actually go through all of the IXPs and obtain the IPv6 addresses of each router in each IXP. Again, the importance here is, well, first of all, that you have a different vector for learning addresses for routers, but also that the importance of these systems is that these systems are much, much more important than the routers that you might get with traceroute, in the sense that these are routers at internet exchange points. If someone went to hack one of these systems, there's much more at stake, okay? What else? Another one is RIPE Atlas, and I'm not talking about RIPE Atlas in the sense of the, you might know these RIPE Atlas boxes. It's essentially some kind of like, I don't know what it is, like a 4G router that they rewrite the firmware, and essentially they give away these boxes, these devices, usually at conferences, so they give that for free. What people normally does is they connect the device somewhere, usually at home or at their job, okay? So the end result is that most of these boxes get connected at ISPs, because it's a technical community, so you get people that attend like these meetings, they get one of those boxes and they put it at the RSP or at home. Now, what's interesting is that in the RIPE Atlas website, you can actually access the data of most of the proofs. Actually, I was stupid enough and thought that I had to crawl the web pages, so I did a script to actually, similar to what I did for the search engine, only to find sometime later that there was like a RESTful interface. Too late. So then I had to do it again, because obviously it's nicer to have a RESTful interface. And what's interesting about this is that it's not really the learning the address of the RIPE Atlas devices, okay? At least my interest wasn't the address of the RIPE Atlas devices, but actually learning /64 addresses or the address of subnets that belong to different clients, if you want. Obviously the IPv6 address space is quite large, and learning, how to say, the prefixes of user networks is not that simple. So if you start from the RIPE Atlas side, you can at least learn a few thousand IPv6 addresses, and you can identify, let's say, a few thousand IPv6 subnetworks. It's not that you might be interested. It's not that you're interested about these devices themselves, but about the networks. And also the thing is that if you learn one network, then in the same way that a customer has been assigned, let's say, a /50 something or a /64, you might be able to come up with the addresses of other subnets, okay? This is about, or the reason for which I found this useful is to, again, learn information about clients, if you want. Not servers. For servers, we have the DNS zone files, all of the stuff that we saw already. But the interest here was, again, to learn addresses that were being employed by clients. Till what time do we have time? 3? 5?
5 minutes.
Okay,
basically.
we're good.
I mean, if you need longer, you can make it a little bit longer.
So, among the conclusions that I can, I mean, this is actually work in progress. So this is right now I'm still measuring stuff. Okay, so the conclusions probably I will have them like in some period of time, like the full conclusions. But for me, the part that was quite interesting was that if you are able to put like all of the pieces, all of the different pieces that we have for enumeration, the results that you can get are much better. And the other stuff that I learned and that I mentioned, during this presentation, was other sources of information that you had them available and that at least me and other people that I know of were not employing. One of them that I have been employing a lot was the PeeringDB database that I mentioned before. I was surprised that I wasn't using that one before that. Peering DB also has information about IPv4 too, so there's lots that you can learn from there. Any questions? Yes.
So when you're putting all these this stuff together, so what's your opinion? What's a rough estimation on how can we successfully scan the whole IPv6 internet compared to IPv4? So as we know, the IPv4 internet can be scanned completely, no problem. So how much % do you think can we scan today with all of these techniques in the IPv6 internet?
I don't have much of a clue, to be honest. But I would say that it is certainly way more than you would assume. Way more. Because of, for example, when it comes to servers and so on, I don't think nowadays it's much of a problem. I mean, so far. Because the information that you get with the DNS, like using search engines and so on, and what you get with DNS reverse enumeration, at least when it comes to servers, I think that you are roughly at the same level of where you are in the IPv4 world. If it comes to clients, that's a different game. Because in the case of clients, you might assume that, for example, they are not publishing the DNS, so you're not going to be able to learn their addresses, you know, with a search engine. It's quite likely that they are also not in the DNS reverse path. I mean, you might, because if you want to map the full address, you might say that your ISP maps, you know, the reverse path till the /64 if you want. But then you still have the, you know, the 64 bits to play with. And there are two options. Either you are delegated the authority to do the DNS reverse mapping, which I have never seen like a case where that actually happens. Like, you know, a normal client doesn't usually do that. You don't connect at home and say, okay, I'm going to make sure that my address maps into a domain name. It's not the case. For instance, in the IPv4 world, it was the ISP that inserted, you know, the reverse mappings for your address. Since the addresses were small, for each address that they were leasing, they would have something that was identifying the client. But since with IPv6 you have, like, you know, the 64 bits to play with, those addresses are not being mapped. I guess that something that an ISP might do is, for example, use wildcards. But if the ISP puts a wildcard, from the point of view of the attacker, that's the same. It's the same thing of the Yahoo case. Let's say if I'm trying to learn addresses of a client and all of the possible addresses have a corresponding DNS name, you know, that's not useful. I'm kind of like surprised about the usefulness of the DNS reverse enumeration, I would say. I mean, obviously for things like mail servers, you do need reverse mappings. Because, I mean, historically speaking, there's like a kind of like, I don't know how to call it, it's not security, it's like a sanity check that if you have a mail server and somebody connects to you, usually you reject the relay of messages if they don't have a reverse mapping. So obviously for, you know, for mail servers, you could expect that. I guess you might expect the same thing for routers, because when people are doing traceroute, usually for troubleshooting, it's nice to have some name associated with the router. But I have seen so many cases. Well, there's this one. I mean, these guys are nice, so it's not that I'm, you know, mentioning them for a bad reason, but. No. Well, Slovenia was C?
SL?
SO?
SL?
SO.
Or
servers. I'm not sure.
Well, funny thing, I have a server somewhere there, but I don't remember them. Okay, it was this one. Okay. Say. This is an educational network in Slovenia, okay? I mean, this is just one example. You do the same thing with RIPE, you get the same thing. You do the same thing with LACNIC, you get the same thing. Hopefully this will work. Let's change this to... So if you think about it, it's kind of like ridiculous. And it happens. It's not just this case, and you have systems that there's no reason for being in the in the DNS reverse mapping, and the fact that they put them there, it makes it so easy to actually find them. Same thing goes for if you look for the reverse zone for RIPE, same thing. Reverse zone for LACNIC, the same thing. And let's say from my perspective, I would probably say that they would be better off removing all this. They are, still giving, too much information. I was also surprised, I should say, about the number of sites that still allow zone transfers. I thought myself that was gone. Like, the kind of stuff that you don't try because you say, okay, at this point, nobody does it. And still, zones all open.
We had zone transfer open last year.
In
our network, I just arrived at the job last year.
And it was open.
They had zone transfer open for nordu.net, which is one of the oldest .net domains. They just said, that's fine.
Yeah, well, actually, there's one thing that I don't remember. The site is something like this. Sense is. I mean, if you look on Google, you are going to find it. This actually is this site is quite interesting. Whatever the real name is, there's a site in which people actually post the results of their port scans. Not just that, they also, for example, different people post different results for different kind of scans or measurements. So some guy, for example, he tried every single IPv4 address for zone transfers, DNS zone transfers, and you can find the list of all of the IPv4 addresses that have open DNS zone transfers available here. Now I got the list, and I assume like, well, if this is posted here, it was probably abused already, so it's probably not available anymore. And yes, it's still available. So, yeah.
So one of the advantages out of IPv6 is to my mind, is the following. In Germany, we have home routers, of course, and I think last year there was some disclosure that there is some router protocol where you can inject something into your router, and it was immediately abused over IPv4. However, when the routers nowadays, you have something like dual stack light, so that means they don't have an IPv4 address on their untrust interface anymore, but only IPv6. But to my mind, you won't find the IPv6 address of the router itself that easy in the internet, because the router itself does not initiate many connections, nor does it has a reverse DNS. So probably the routers are the home connections are a little bit more secure or safe, because you won't find those IPv6 addresses.
Well, what I was mentioning about RIPE Atlas is exactly that, because in many cases, I had one at some point in time, many people have the RIPE atlas proof connected at home.
Yeah, at least in Germany, then it's out of a different prefix.
So you say that the prefix that the router is employing is different from the one that they are using for the local subnet.
Exactly.
I don't know.
At least in Germany, it is.
Okay. Yeah, there are other. I mean, when it comes to this, is not, let's say, not that related, but it's for me it was also interesting to see. You know, the size of the prefixes that ISPs were leasing customers. For example, what I've seen in Latin America, I haven't looked at many different ISPs because there's not that many people, not that many ISPs that have deployed IPv6, but it's been quite usual for them to lease a /64, for example, which in a sense makes it like easier to, you know, it reduces the search space in a sense. Because if they are granting the /64s, let's say, from the same place, it would be easy to find them. But yeah, I guess it depends on the policy that they employ. Like, you know, if but at the same time, I'm thinking out loud. You're saying that they employ a different prefix for the router than for the internal network. Now, from that point of view, I would assume that it's extremely likely that the prefixes that they employ for the clients, they follow patterns. Yes. Now, if you learn one, it's quite likely that you learn all of the others. So that's why I'm saying maybe like finding the home network maybe might be more difficult, but finding the routers, they probably, you know, get all of the addresses from the same pool anywhere.
So, however, there's a /64 for the transfer segment between, for example, Deutsche Telekom and my home router. However, inside this segment, the router does slack, so it uses the MAC address,
okay,
host ID. So, yeah, it's kind of not easy to find it anyway.
Well, the thing with the MAC, I mean, depends, but the other thing that you might have there is that let's say Deutsche Telekom. I mean, I don't know what are the devices that they employ, right? But if they purchase the CPEs, like, you know, in large numbers, which is what you would assume, the MAC addresses are going to be consecutive. Like, it's the same thing happens if you go to some, you know, regular shop where you can buy electronics. You find, like, for example, 2 IP cameras. You look at the MAC addresses, usually they are contiguous, because at the end of the day, they end up being like serial numbers. It's not that the vendor randomizes the address when they are manufacturing them. So I wouldn't be surprised if you look at the CPEs, let's say Deutsche Telekom or whoever that is, that you find out that all of the MAC addresses are clustered. So you know that, you know, the MAC addresses are going to be in this range. So it's going to be easy to reduce the search space a lot. I'm not saying that it's going to be trivial, but what I'm saying is that the search space might be smaller than you think.
Any more questions?
Thanks. I'm just curious, when you try to perform the reverse domains to the IPv6 address, from time to time, do you came across with some of the very interesting domains, or those are unknown, but they are not supposed to be publicly available or publicly seen in the internet?
So you're wondering why they are there?
I'm wondering, have you seen a lot of cases where those are supposed to be secret domains for the organizations, but eventually it's just publicly available?
Well, I don't know if secret, but there have been, I mean, for example, even if you look at, even for example, I don't know if it was in LACNIC or RIPE or in one of the registries, you get like some boxes like, you know, engineering server, or which looks like it's not stuff that should be published, you know what I mean? It looks like it's information that should be internal for the organization, but, you know, somehow they publish it for the whole world. I don't know the reason for that. I consider that that's a bad idea. I mean, you make it way easier to find, I mean, not only to find the systems, because one thing is just to find like an address that is alive. That's one thing. But when you get a string that gives you a description of what the system is supposed to be about, that's even more interesting. If I find an address that is alive, I don't even know what that is. I don't know if the system is. But if you get a domain name that says like payment blah 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 or database blah blah blah, and there are some like that, that's for me that's like too much information. And that's part of the project that I was working on. Part of what was very interesting for me wasn't just the IP addresses, but for the most part the domain names, because having learning addresses is like, I don't know to what extent that's it can be interesting, but when you have a name associated with the address, that gives you more of an idea of what that box is about.
Any more questions? So then, thank you, Fernando.
Thank you.